Welcome to the probability video for mathcelebrity.com. In the next few minutes, I'm going to walk you through the definition of probability, formulas for probability, how to write probabilities, and a few probability examples. So let's get started. What is probability? Probability is just the likelihood of something happening. Some examples include the probability of flipping a head on a coin, rolling a 6 on a single cube or die, or being born on a Sunday. Now, before we get into the formulas and the details, there's a few probability terms you should know. First, an experiment. It's a repeatable process with a set of possible results. An outcome is a possible result of an experiment. The sample space is all the possible outcomes of an experiment. And finally, an event is one or more outcomes of an experiment. Now, the general probability formula goes like this. The probability of an event happening equals the number of ways the event can happen divided by the total number of outcomes. How can we write probabilities? 3 ways. First, a decimal, second, a fraction, and third, a percentage, which we'll get into in just a moment. Let's take an example. Let's take a quarter. It's got 2 sides, one head and one tail, and let's flip it. And we want to know the probability of flipping a head. If we go back to our general probability formula, we want to know the total number of heads divided by the total number of coin faces. Well, we know that a quarter or a dime or a nickel or a penny has 2 sides, one head and one tail. So there's only one way to get heads out of the 2 possible coin faces. So therefore, the probability of flipping a head is 1 over 2, 1/2. Now, as we said before, you can also write probability as a percentage or a decimal. So in this case, the probability of a head is 50% or 0.5. Moving on, let's go through rolling of the dice. A standard die or cube has 6 sides, 1, 2, 3, 4, 5, and 6. And we want to know, for example, the probability of rolling a 3. Using our general probability formula, we want to know the total number of 3s divided by the total number of die or cube faces. Well, on the standard die, there's only 1 3, so our numerator is 1. And the denominator is 6 because there's 6 sides or 6 faces. So our probability of rolling a 3 is 1/6. Now we can also write this as a percentage or a decimal. So the probability of rolling a 3 is 16.67% or 0.1667. The 2 events we just covered are what's called equally likely events. And when you have these, there's actually a shortcut formula you could use. For equally likely events like coin flips and die rolls, the probability for each event is 1 over n, where n is the number of possible outcomes. So with coin flips, n was 2, and die rolls, n was 6. Now let's take it a step further. You won't always have something neatly packaged like equal possibility outcomes. So let's try one where the possibilities are not equal. Let's take a fruit in a bowl example. Suppose in your kitchen you have a bowl of fruit, and inside the bowl you've got 3 apples, 5 oranges, and 6 bananas. We want to find out the probability of picking an orange. Well, using our general probability formula, the probability of picking an orange equals the total amount of oranges in the bowl divided by the total amount of fruit in the bowl. Well, we have 5 oranges, and the total amount of fruit is found by adding up all the fruits in the bowl. So 3 apples plus 5 oranges plus 6 bananas is 14 fruits. So our probability of picking an orange out of the bowl equals 5 over 14. Written in percentage or decimal format, we've got 35.71% or 0.3571. Now let's move on to probability postulates. The first one is for events. For any event A, the probability of A is always going to be greater than or equal to 0 and less than or equal to 1. And a few notes on this inequality. A probability of 0 means the event is impossible. A probability of 1 means the event is certain. It's going to happen. A probability of 0.5 or 1/2 or 50% means the event is equally likely to happen as it is not to happen. A probability greater than 1/2 or 0.5 or 50% and less than 1 is likely to happen. And going on the other side, a probability less than 1/2 or 0.5 or 50% and greater than 0 is unlikely to happen. Moving on, let's talk about the sample space postulate. For a sample space S, which is all possible outcomes, the probability of S is 1, since it's all possible outcomes. And finally, we've got the empty set postulate. The probability of the empty set, which is an event without outcomes, is 0. So that is all today for the probability video. I want to thank you for watching, and I will see you in the next video.